All right, today we're going to look at generating equivalent expressions. And another way to think about that is combining like terms. So when you hear equivalent expressions and what you're going to do with those, think about combining like terms. The first thing we're going to do is look at the parts of an algebraic expression so that we understand the vocabulary and what each of those parts looks like and what it's called. So terms, that is your parts of the expression that are separated by addition or subtraction signs. So for example, in this 12 plus 3y squared plus 4x minus 2y squared plus 4, each of these parts in between our operations of addition and subtraction, this is a term. 12 is a term. 3y squared, that's a term. 4x is a term. 2y squared is a term, and 4 is a term. Then we have our coefficients. Those are the numbers that are multiplied by at least one variable. So in this, 12 is a constant, it's not a coefficient. The coefficient here, we've got 3 in front of the y squared, so that's showing me multiplication, and 3 is my coefficient. So for 4x, 4 is the coefficient. It does not include the variable, it's the number in front of or to the left of the variable that's showing multiplication. 2y squared, 2 right here is my coefficient. And then I have another constant, so there's no coefficient there. The next thing we need to look at is like terms. Terms with the same variable or variables raised to the same power or powers. So looking here at we're looking at the same expression here each time. 12 plus 3y squared plus 4x minus 2y squared plus 4. So our constants are always going to be like terms. So they've got the same variable, there isn't one. And they're raised to the same power, it's 1. So 12 and 4 are like terms, and we could combine them. The next one I have here is this y squared and the y squared. I can combine 3y squared and negative 2y squared, or minus 2y squared. And when I do that, when I am combining, you do not change these variables. They stay exactly the same. Essentially, think of it as like I have 3, and then you can put anything in place of that y squared. 3 coins. Well, if I have 3 coins and I'm going to take 2 coins away, I'm going to end up with 1 coin, but I'm still talking about coins. So when we're talking about these variables, our y squared, when we combine, stays the same. All right, let's get started here. When an expression contains like terms, you can use properties to combine the like terms into one single term. The result is an expression that is equivalent or the same as the original expression. So my first example here is 6x squared minus 4x squared. Remember, I told you we do not change the variable and exponent, so that x squared stays the same. And the only thing we do here is 6 minus 4. Well, 6 minus 4 is 2. You could also think of it, because this negative really goes with that 4, you could think of it as 6 minus 4 or 6 plus negative 4. This means the same thing. And either way, this may be easier to understand when you're working them, because think about combining and kind of like adding them. All right. So the next one we're going to look at, number 2, 3a plus 2. Remember, I've got these parentheses here, and that's multiplied by b plus 5a. So when I have a coefficient or some number outside of these parentheses, we need to distribute that into each term in the parentheses. So 3a just stays the same and it comes down. Then I've got my plus 2 times b is 2b, and 2 times 5a is 10a. Notice that my operations, these were part of my multiplication, but everything was positive, so I still stayed with adding. All right, now I have 3a plus 2b plus 10a. So I'm looking for any terms that have the same variables raised to the same power, and I have here an a and an a. Those are raised to the first power, but we don't ever write that first power. So 3a plus 10a is 13a plus 2b. The other thing I want you to catch is we should be writing these in alphabetical order. That's not something we're going to really talk too much about in 6th grade, but notice that I'm going to do it. You may not do it. It's not going to count it wrong, as long as you do the math part in the combining correct. 3 is y plus 11x minus 7x plus 7y. Notice when I'm doing this, I'm identifying. I have a y and a y. Those are the same terms. They both have the same variable with exponent. Then I have identified x and x. So in here, I did my x's first because alphabetically x comes before y. I did 11 minus 7. Notice my x stayed the same. So 11 minus 7 is 4x. And then I have y plus 7y. And if I have 1y and I add 7, I'm going to have 8 y's. All right, number 4, I have 4a raised to the 5th power minus 2a raised to the 5th power plus 4b plus b. So here I have my a to the 5th power, and I have 4a to the 5th minus 2a to the 5th. 4 minus 2 is 2. A to the 5th stays the same. And then I have 4b plus another b, and 4 plus 1 is just 5. So right here, this is as simple as it gets, and we have the same value here that we started with in our original expression. This is equivalent or the same as 2a to the 5th plus 5b. All right, number 5 here, I have 6x squared minus 4, and now I've got some more parentheses, and then I have x squared minus 1 inside of them. First step, we need to distribute those. We need to get rid of those parentheses. So I have a negative 4 times x squared. That's going to be minus 4x squared. And then I have a negative 4 times a negative 1. So when we're doing this distribution, we need to make sure we're using that as that operator for our signage. So negative 4 times negative 1 is a positive 4. Now I'm going to be adding. The next step is to combine my like terms. I have 6x squared minus 4x squared plus 4. So we have like terms in our x squareds. 6 minus 4 is 2, so I have 2x squared plus 4. All right. The next one here, I've got a little note here, and I know this is kind of messy, but I'm going to read it for you. Variables and exponents must match. I want you to make sure you write that down. The variables and exponents must match, because this one's a little tricky here. I have z squared plus z plus 4z cubed, so raised to the 3rd power, plus 4z squared. The only terms I can combine are the ones that have the same variables with exponents. So that's my z squared and my z squared. So I just have 1 here and I have 4 here. So how many z squares do I have? 5. All right, so I put my 5z squared here, and I'm going to write these in order from 1 to up when I do my powers. You don't have to do that. Just notice that's what I've done here. There's only 1 z and there's only 1 z cubed. So it's z plus 5z squared plus 4z cubed. All right, if you have any questions on this, please let me know. This is going to come with practice. I feel like I need to give you one to try on your own. Let's see here. Let's go 2a squared plus a cubed minus 4a, let's go minus, the plus 5a squared. All right, I want you to work on that. All right, so I'm going to zoom in here. All right, so hopefully you saw that your variables and exponents must match if you're going to combine. So we have an a squared and an a squared. I can combine those. I have 2a squared plus 5a squared. That is going to be 2 plus 5 is 7a squareds. All right, and then I have an a cubed, and it's plus a cubed, so plus a cubed. And then I have a minus 4a. It does not matter where you put this, but I like to do these in the correct order. So I would put my negative 4a up front, and I've got to remember this is positive, I'm going to plus. I'm going to add. So you could have written this as 7a squared. I'm going to try to write it in the same order you would probably have written it, plus a cubed minus 4a. So these are exactly the same. What I've done is I've just written them in the proper order, which was something you'll learn probably maybe 8th grade or algebra. So these are the same. It doesn't matter which order you wrote them. The biggest thing is making sure your signage and your operations are correct, but that's what you should have gotten. I hope you did really well and have a great day.